Hey, Mia from Make It Future here, and in this demo we are going to look over one of the many solutions that we have built for one of our clients, and in this case it's about the transportation company that is carrying goods across Europe. And their struggle was that they had lots of messages on WhatsApp requesting offers, and they couldn't keep it up with the volume. So with this workflow, we solved this problem by getting all those messages, analyzing them with AI, and based on the pickup location from that message, we are searching for the closest car to that particular location, and deliver all those information in Airtable so that the client can see the offer and which is the closest car to that particular pickup. So first I'm going to execute the workflow. We are going to leave it to run, and we are going to start to analyze the workflow. First, we have the WhatsApp node, which is a pinned message that we already received previously. Next, we have a filter which with two conditions. One is basically the sender name doesn't need to contain quick trans, which is always present in the client's employees names. And the second one, it's the message length needs to be at least 30 characters so that it's treated as a true offer request, so that we can filter all the good, okay, and those words. Alright, next we are using an AI agent. We could use an information extractor, but in this particular case we use the AI agent as it was the better solution for this workflow. Okay, first we give the input from the WhatsApp message, and the system message is the instruction for the AI that is written in XML. Next, of course, we have the chat model and the structure output for the desired output of the AI agent. Next, we are using another filter to make sure that the request is a true one. Alright, next, in this node we are not analyzing, but basically we are getting the latitude and longitude for the pickup address, so we can use it in the further nodes. Alright, next we get all the cars, not quite all the cars. We are getting the free cars, and we are getting the busy cars, but only those that end their current order before this one is going to start. Okay, and we are splitting these two, the free ones and the busy ones, into two different paths. The free ones we are sending to the one of the above, so we are mapping. The difference is just the latitude and longitude. For the free ones we are getting the current location, and for the busy ones we are getting the future location, which is basically where the current order is going to end. Alright, we are going to merge those inputs and aggregate them into a list, and then we estimate the distance. We're using Haversine formula, which basically it calculates the straight line between 2 points on the globe. Yeah, so here we are doing some calculation, and we are also using some correction factor for the output to be as accurate as it can be. Of course, it's not as accurate as using a service provider. That's the reason why we are using it here. So once we are getting the estimation, we only output the first 5 cars closer to that pickup location, and then we format the output for this one to calculate the exact distance and time for our cars. And also you might ask why we are using 2 different code nodes, and that's because we change a lot the maps provider, and I just wanted to only change the code here and don't touch anything else from on this one. All right, we have next the structure output, which basically it structures the data as the client asked, and we delivered it in Airtable, where we create a record and we add the closest cars to that record. Okay, that's it. And yeah, the client, it helped a lot the client to manage the offers that they get.